in this screencast, we're going to be looking at zonation. Zonation is how species abundance, like the populations of all the different species, which is technically a community, changes along an environmental gradient. And so if we think about an abiotic factor, some abiotic gradient, usually it's something like altitude, latitude, tidal level, distance from a shore, things like that. If we were to measure the size of the different populations of species from one point to another along there, would the distribution of those species change? What I mean by that is if we were to move from the bottom of a mountain, so if we're doing altitude, all the way to the top of the mountain, how might the community, so that's all the different populations of the different species, right? How might that community change as you move further and further up the mountain? So you can see this one is kind of starting with deciduous trees. We might see a lot of those and some other plants associated with that. As we get higher in altitude, it gets a little bit colder, we might start to see the coniferous forests there. As you get even further up the mountain, things are a lot more frozen. The growing season's not as long. The water might not be as available, and you might start to see different lower lying plants and so on until you get to the top where you're really only seeing mosses and lichens. So the community you see is changing as the altitude is changing. So it's along that environmental gradient. That also works for rocky shores. This is a very common example that we'll be looking at quite a bit. So if you have low tide and high tide, so if you've ever been to a beach where the tide goes out and the tide comes back in, maybe somewhere in England or in the northern US or Canada, you can see these big changes and shifts in tides. And so when the tide goes out, if you're on a rocky shore, these areas are going to be more exposed to the air because as the tide goes out, then the ones below the low tidal zone. So this water might go from here all the way up to here. And so you can measure the community as you move up the intertidal zone from, usually they'll measure from the low tide all the way up to the high tide, just seeing, how does this community change? Because some species are more tolerant than other species to being exposed to air. So you can imagine the species down here wouldn't be able to tolerate being out in the open, in the air as much as the ones like these limpets can really tend to handle it a lot more than the ones as you get further down. So when we make these measurements, the way we make these measurements is we use transect sampling. So this is overly simplified transect sampling, but you would run a line, and you might have done this in ninth grade. You run a line, a distance, so maybe this would be low tide and this would be high tide, and you would put a quadrat and count all of the species, how many of each species there are in that quadrat at, say, 1 meter, 2 meters, 3 meters, and 4 meters as you start to move up. If we were going up the side of the mountain, same thing. You maybe would put quadrats down at every certain change in elevation and then count the number of different species, the number of individuals of each species. So you're essentially looking for the density of each species in the quadrat. So what we end up doing with that data a lot of times is making something called a kite graph. So a kite graph is showing us, this is the low to high water mark, right? So this is that rocky shore community that we were looking at earlier in the earlier slide. And you can see that we've got each species is plotted kind of separately. This is kind of plotted like, in some ways, more like a bar chart, because you're not plotting, this axis isn't changing. You just have the individual species going along here, and then how many of them are found along the way. So they're elongated figures. They're drawn at a baseline. Each kite is a change in the species abundance across an area. So this kite, and this kite, right? So each kite is going to represent a different species, and how their abundance, what their population size is going to change as you move along the transect. So this would be how you laid the transect down at 0, 1 meter, 2 meter, 3 meter, 4 meter, and so on. And you would look at how many species you would find, or percentage cover in that general area. So in this particular kite graph is that this width shows you how many individuals there are. So from 0 to 10 would be this wide. So I think the only place on the graph that it looks like there would be 10 individuals would be species B at 2 meters along that watermark. So if you were doing the sampling, if this were the transect, if this was low water and this is a high water mark, this is 0 meters, this is 1 meters, this is 2 meters, and at 2 meters, they found maybe 10 individuals. That was the abundance at that one mark. Okay. So, so you can see that these are each meter is where you have that sampling happening. So you can see how many there are. And it's calculated by the width of the height, so you can see how many individuals there are. So there's 10 here. There's less than 10 here. You'd have to measure it. It looks like there's probably 7 or 8 at this point, and then even fewer, maybe 5 here, and fewer and fewer. And how can this allow us to make assumptions about things like fundamental and realized niche and species and competition? So if you're thinking about the abundance, if you're first just to describe the abundance, like a species A, we would say species A does not exist until at least 5 meters above the low water mark. So if this species A doesn't exist until here, it's possible that it doesn't show up because its fundamental niche, it just can't handle being underwater that long. So it could be that, or it could be in its realized niche. Possibly this species could inhabit way further down here, but there's some competition maybe going on between species A and species B. So we don't see it as frequently together, because maybe at these meters above high water mark, maybe this particular species B, is a much better competitor. So it might be excluding species A from this region along that rocky shore. And it looks like it's actually not only excluding this species, but possibly this species. So you can see this guy probably has a fundamental niche that's pretty great, because I imagine if it can tolerate here and it can tolerate here, it could probably tolerate in between as well. But since we don't see it there, there's a good chance that we've got some competition happening here, and it's pushed into two extremes on a realized niche. Now I'm just going to talk to you about how to make a kite graph. So if you were given this data, right, and you could put it together on here. So you have one, you spread it out so you have lots of room. So each species gets its own kite, and you've got, the abiotic factor, whether altitude or distance from low water mark, goes along here, right? So you've got 1 meter, 2 meter, 3 meters, 4 meters, 5 meters. And then you take those measurements. So at 0 meters, none of these guys are around, right? So there's no width at 0 meters. And we still don't get anything until 1 meter, species C. There's 6 of them. So you would want to say, all right, 6 would be this. You'd measure that with a ruler. Species C, you would make that determination if you're making your own graph, but maybe it's from here to here. And then so you would draw a line from here to here, 3 this way and 3 that way on an axis to make 6. So if you have one line going up, you do half this way, half that way, right? And then it looks like, oh, they disappear again. So then you can just draw your lines from the axis out and then back in again, okay? And then we don't see them again until we actually get some measurements at 5. And it looks like maybe at 5 meters, maybe there's 9 of them. So if this is the axis, you do 4.5 that way and 4.5 that way. And then it looks like there's 4 at 6 meters. And then so you go 2 this way and 2 this way. And then you can just connect those lines around it. Okay, so you can pause this and kind of take a look at how you might determine that. So with species B, if you drew a line all the way up, and you would go all the way up to the 2 meter mark, and from that line, if there's 10 of them, you do 5 units that way and 5 units that way, right? So you can get a nice even bit around there, and then keep going up and marking the distance, kind of cut it in half and mark that way, and then you can connect the lines when you're done. And sometimes you might see them, actually not, this is another rocky shore one, but they've got the axes flipped a little bit. That's common as well. Okay, so this doesn't have to be rocky shore. It could be altitude. It could be, another abiotic factor, looking at a transect. But again, when we're looking at zonation, we're looking at the change in the community over some, distance. Okay, so it's a change in community over a distance, and usually that distance is as that's moving along, there's a change in an abiotic factor. There's something changing, whether that's altitude or, with this example of the rocky shore from high tide, how much exposure it's getting to the air. So that's an important aspect, that you can define the idea of zonation, referring to the changes in community along an environmental gradient. Okay, so it's those changes over an environmental gradient, some distance.